Hey everybody, so welcome back to my final exam review. This is video number 2, and in the last video I reviewed skeletal muscle physiology and resistance training adaptations. Now today I'm shifting our focus to aerobic training and overall discussing how consistent endurance exercise produces overall long-term adaptations within the cardiovascular, respiratory, and muscular systems. Now, one of the major concepts we learned throughout the course is that aerobic exercise places a prolonged demand on oxygen delivery and ATP production. Now, unlike resistance training, which primarily relies on ATP-PC or the ATP phosphocreatine system, and overall anaerobic glycolysis, endurance exercise depends heavily on aerobic metabolism to continuously produce ATP over an extended period of time. Now, as I'm running here on the treadmill, my muscles immediately increase their demand for ATP. So to meet this demand, my cardiovascular and respiratory systems begin working together to deliver more oxygen to the active muscles. One of the first responses to aerobic exercise is an increase in heart rate. As heart rate increases, the heart pumps more blood each minute to supply oxygen and nutrients to the working muscle. And another important concept is stroke volume. Stroke volume is the amount of blood ejected by the left ventricle with each heartbeat. So during exercise, stroke volume increases because the heart fills more completely and contracts more forcefully. Now, together, heart rate and stroke volume determine cardiac output, which is the total amount of blood the heart pumps each minute. Now, cardiac output is calculated using the following equation, which is heart rate multiplied by stroke volume. And as exercise intensity increases, cardiac output also increases to match the growing metabolic demand. So with consistent endurance training, one of the most important physiological adaptations is an increase in stroke volume. Because the heart becomes more efficient at pumping blood, trained individuals are able to better deliver oxygen with each heartbeat. So as a result, resting heart rate often decreases just because the heart no longer has to beat as frequently to supply the body's oxygen needs. And a lower resting heart rate is one of the classic signs of improved cardiovascular fitness. Now, I should be starting to slow down here, and we will be transitioning over to a stationary bike. And as we're transitioning, the exercise intensity is going to increase just slightly. And, because intensity is increasing, so will my oxygen demand. And this brings us to one of the most important concepts in exercise physiology, which is VO2 max. Now, VO2 max represents the maximum amount of oxygen that an individual can consume and utilize, that's very important, during maximal exercise. And it is widely considered one of the best indicators of aerobic fitness because it reflects how effectively cardiovascular, respiratory, and muscular systems work together to transport and use oxygen. Endurance training can improve VO2 max through several physiological adaptations. First being an increase in blood volume, which allows greater oxygen transport. Second would be an increased capillary density within skeletal muscles to improve oxygen delivery by shortening the diffusion distance. And then another major adaptation is an increase in both the number and size of mitochondria. So since mitochondria are the powerhouse of the cell, guys, pulling that back from middle school biology, but they are the primary site of ATP production. Increasing mitochondrial density allows muscles to produce ATP more efficiently using oxygen. So our notes also discuss oxidative enzymes, which become more active with endurance training. These enzymes accelerate the biochemical reactions involved in aerobic metabolism. So it allows ATP to be generated at a faster rate during prolonged exercise, is what that means. And another important muscular adaptation is improved fuel selection. And as aerobic fitness improves, the body becomes more efficient at using fat as a fuel source during moderate intensity exercises. We slowed it down here. And as I begin my recovery stage, my heart rate and breathing gradually return towards resting levels. And although exercise has ended, my body continues consuming oxygen at an elevated rate as it restores homeostasis. This recovery period reflects how efficiently the cardiovascular and respiratory systems work together following exercise. And one of the biggest themes throughout the course is that the body is constantly adapting to repeated stress. So with constant aerobic training, these physiological adaptations become more pronounced and allow exercise to feel easier even when performing the same workload.